Hello student, welcome to my lecture videos. In today's video, we will be talking about periodic table. Actually, more precisely, we'll be talking about modern long form periodic table. Actually, what you are seeing in the screen. So there is a little bit of history of the periodic table. Periodic table was first, I will say tried or invented by Mendeleev, and you can see the name of the scientist here. So if you look at it, it was originally started by Mendeleev, but actually, it didn't succeed. So although it has a pioneering work in this particular area, but there was significant limitations. I think you can read on your own. So we will be discussing about this modern periodic table, or called modern long form periodic table. As I have already indicated while discussing elements, the periodic table is a table in which all the elements are arranged in terms of its symbol as per the increasing atomic numbers. Let me repeat one more time. In modern long-form periodic table, elements are arranged in terms of groups and periods in terms of increasing atomic number. So while Mendeleev was creating his own periodic table, that periodic table was created based on atomic mass or atomic weight. The long-form periodic table is created based on increasing atomic number. Actually, that make all the differences. So without going into details of the Mendeleev, what is its merit, what is its demerits, let's concentrate on this long-form periodic table, which is used for last couple of centuries. And it is expected that it will be continue to be used because it is a pretty, I will say, advanced, and it is serving our purpose pretty well. So if you look at this periodic table, the elements are arranged in terms of something called groups and periods. So if you look at it, these vertical lines is called groups, and this horizontal line is called periods. There are 18 groups, 1 to 18, and there are 7 periods, 1 to 7. So in case of a groups, the numbering are in two ways. You can number the groups starting from 1, 2, 3, 4, 5, 6, 7, 8, and then up to 18. And also you will find there is another way of marking the groups. That is called 1A to 8A, 1A to A, and then 3A to 8A, and then 1B to 8B. So actually both the numbering system has some merits and some limitations, but we will discuss in appropriate time. So the point of discussion is all the elements. Right now probably we have around 117 or 18 elements known to us. Those elements are arranged in the periodic table in terms of its symbols. For example, hydrogen is H, calcium is Ca, carbon is C, chlorine is Cl, as per their increasing atomic number in groups and periods. So if you look at it, this one is actually the modern long-form periodic table. But in addition of having these elements arranged in groups and periods, it has really wide-ranging applications. For example, it can help you to classify elements in different ways. For example, the elements can be classified into metals and non-metals. So if you look at, as per the legends, any element with a light yellow background are metals, and elements with light greenish background is called non-metal, and there is also a light purple color background, they are called metalloids. So elements can be broadly classified into three groups. For example, the elements from group 1 to I will say up to 13, or you can see there is a line here which is called metalloids. There are 8 metalloids like boron, silicon, arsenic, all these. And the elements in the left-hand side of the metalloids is called metals, and elements which are placed on the right-hand side of the metalloids, they are called non-metals. Yeah, and also there are two set of elements called lanthanide and actinides, which are kind of rare earth elements and which are placed on the bottom. Actually, they should have been placed here, but in order to keep them in a place where their properties are, I will say, remarkably similar, that's why it is not possible for them to be included in the main body of the periodic table. That's why they are placed in the lower part of the periodic table. So lanthanide and actinides, they are metals, but lanthanides and actinides are very similar in terms of their properties, and each one of them have unique use in our modern science and modern, I will say, industries. That's why they have been placed in a separate place, and they are studied also very separate. In addition of this classification, we talked about metal, non-metal, and metalloid. There is also another way of classifying elements. For example, group 1 elements, if you look at it, this group 1 element, so if you look at group 1 element, they have a separate name. They are called alkali metals. Group 2 is called alkaline earth metal. And group 3 to 12, all these are called transition metal. Similarly, group 18 is called noble gas, or sometimes it is called inert gas. These elements rarely react because they are very non-reactive. We will explain why appropriately in probably chapter 9. Similarly, group 17 or 7A is called halogens. So if you look at it, and also we have already explained, these elements are called separately lanthanide and actinides. So depending on similarity and their properties of the elements are classified metal, metalloids, and non-metals. Also, they can be classified depending on their specific place in a group, like alkali metal, alkali earth metal, alkaline earth metal, halogens, noble gas, or inert gases. And each of these group of elements has reasonably good similarity. That's why they have been given a separate name, and they have separate use also, in a sense. In addition, in subsequent chapters, you will find that the periodic table will also help you to give a lot more information than simply classifying the elements. For example, we have already discussed that, an atom is neutral, but atom can be converted to an ion by loss or gain of an electron. We have already discussed, the atom can be converted to two ions, cation, which is positively charged, and it is anion. It is positively charged and it is negatively charged. So which element produce what type of ions, although there are a lot of variabilities, but still we can get a primary idea what kind of ions they prefer to produce. For example, I will tell you, group 1 elements like to produce 1 plus ion. 1 plus ion means hydrogen, lithium, sodium, potassium, rubidium, cesium, they like to produce 1 plus ion. For example, sodium lose 1 electron and produce sodium 1 plus ion. Similarly, group 2 will produce plus 2 ions. In case of a transition element, they produce cations. They all produce cations, but their charges are variable. They can produce more than one ions depending on their particular reaction. For example, I will tell you iron. In case of iron, it produces cation, but also it can produce more than one type of cation. Iron plus 2, iron plus 3. Similarly, chromium can produce plus 2, plus 4, chromium plus 2, plus 3, and plus 6. So all these transition elements exactly are known for their capabilities to produce more than one type of ions. Similarly, as I said, group 18 or 8A elements, they don't produce any ions, but group 17 or 7A produce 1 minus ions. It means fluorine can be producing a anion, F1 minus. Similarly, chlorine, bromine, and iodine, they all produce. Similarly, group 16 produce minus 2 ion. And group 5A or 15, they produce 3 minus ion. Okay? So these are, I will say, the starting point, but the types of ion produced by an individual elements are widely variable. More discussion will come in appropriate time. This is the good starting point. That group 1 produce plus 1, group 2 plus 2, group 3 to 12, the transitional element produce cation, but they are capable to produce more than one type of cation, and it depends on the elements. And in case of a non-metal, halogen produce minus 1, oxygen, sulfur, group 16 or 6A produce 2 minus, and group 15 or 5A produce 3 minus in a sense. So these informations are very, very important in your next chapter, in chapter 3, when we will be talking about the compounds. So as I said, chemistry is the science of exception. In this periodic table also, there are few exceptions. For example, hydrogen. It is a non-metal because it has a light green color background, but also it is placed in group 1. So hydrogen is a non-metal, but it is clubbed with the other strong metals, alkali metals in group 1. That is one of the exception, because due to their similarity in electron distribution, which we will study in what is called chapter 9. So more or less, the periodic table helps you to organize the elements in groups and periods as per their increasing atomic number. And also, the elements which are in same group, they're supposed to have similar properties. Mind it is similar properties, not same properties. So there will be individual differences, but there will be some similarities. Those elements belongs to a particular group. We will talk about the variation of the individual properties, like what is called periodic trend of the properties of the element in chapter 9. But for the timing, the information what we discussed is very useful for this particular chapter. And also, there is a periodic law which is not very clearly mentioned in your textbook. Let me write it down. That is called something periodic law. So what is periodic law, based on which the periodic tables are created? Physical and chemical properties of element are periodic function of atomic numbers of the element. What exactly it is saying? if you arrange elements with the increasing atomic number, after a certain time, the properties of the elements will reappear. So let me first explain what is called periodic function. So periodic means anything which reappears after a certain interval. For example, our weather is periodic. Every December, January, the cold weather is reappearing. Similarly, during the month of June and July, summer reappears. So periodic means any event which reappears after a certain interval. In case of a periodic table, so if you look at it, the properties of the element reappears after increase of the atomic number by 18. So for example, if you look at it, let me explain it in terms of a better clean periodic table. So if you look at this one, this is also a periodic table. So for example, sodium is a metal. It's a very strong metal. For example, potassium, it is a strong metal. So if you look at it, once you arrange them in increasing atomic number, potassium followed by calcium and all others, and then you come to krypton, slowly you will find the metallic property of the elements are decreasing, and as soon as it's come to arsenic, it has become metalloid, and then ultimately bromine and krypton, they are non-metal. So if you look at it, it means when elements are arranged in the increasing atomic number, slowly it starts with the metal, then slowly metallic property decreases, and then it's become metalloid, then it become non-metal. Then you look at it from 36, when it is become 37, it is rubidium, it is becoming metal again. So it means in the periodic table, after certain increase of the atomic number, the elements' physical and chemical properties reappear, like the way we explained the metallic characteristics. Krypton is a non-metal, but as soon as it increased to 1 to rubidium, the property becomes similar to potassium. So that is the reason we say that chemical properties and physical properties of the substance are reappearing after a certain interval of increase of the atomic numbers. That's why it is a periodic function in a sense. Also, just to tell you, the metalloids, what we talked about, these metalloids are, are a type of element which has some property of the metal and some property of the non-metal. And sometimes they are also called semiconductors. And they are very useful for today's modern electronics. So the semiconductors are based on these metalloids, and metalloids, as I said, they have some properties of the metal and some properties of the non-metal. And actually, metalloids in the periodic table works as a demarcating line between metals and non-metals. Element placed on the left-hand side of the metalloids are metal, right-hand side is called non-metal. So that is for this periodic table for today. And we will see you in the